Individual grandparents spoiling her. My wife, my mother. It's so interesting, actually. Yeah. Yeah, Mana message to Nadia. I also believe so. Maybe not worth huge. For some reason, biggest point. It's not actually a city thing. I used to go to them anyway. Get you know, they would not. I feel like I should. The gate now. Yeah, yeah, usually work. They look fine, but update them. I know you wrote those like quickly through like the locked outside, like the opposite, like so. That was like your final Thursday. We're willing to give you one. I was later, yeah. Because I think that's the same thing I know. Like the view that we like weren't exactly lying on it. It's like, oh, I could be just 8 years. And I'm like, whoa, that's not getting crazy. But, yeah, I mean, I love it. It's an interesting debate because like people that have gone to the awesome like we're not the back out of that one. Like that's how you do that. Yeah, like both ways. But then the other thing obviously like you are saving that $6 as well, which I think is not a huge. I think that's secondary to the like the debate. Like, you know, that's like the sector. It's spent it's nice. Yeah, just easy. It's like
So, good afternoon. Thank you for coming to the first seminar of civil seminar of this of 2023. Happy New Year to all of you. And today we have a very special guest. It's a distinguished lecture. And that's why we open it for both our undergraduate and graduate students. And as you can see, the title is very inspiring. I really like it. So the title you can see on the screen, Civil Engineering, the future has never looked brighter. City of London, City of Toronto perspective. And it's my pleasure to introduce Michael D'Andrea. So Michael is the Chief Engineer and Executive Director of Engineering and Construction Services for the City of Toronto. So he has big responsibilities not only dealing with engineering, but also the policy and the political side of management engineering projects in the city of Toronto. You all know Toronto, it's the largest city in Canada for sure. And Michael, in his current role, he leads about 650 professional and technical staff, was responsible for the engineering design and construction of Toronto's water, wastewater, stormwater, transportation, and solid waste infrastructure, which are valued of about $1 billion annually. So very large portfolio. And he is leading some of the largest and most complex projects. Michael, friend of Western and the department, he kindly serves on the advisory group of the department, giving us excellent feedback about various matters. He is a graduate of Western. He did his undergrad and the master's degree from Western in civil engineering. He was recently recognized by a very, very prestigious award for his lifetime achievements, which is a 2021 Ontario Professional Engineers Award Engineering Medal for management. We have something in common between myself and Michael, that we both have very good friend, which is Professor Badur, who was Michael supervisor, and he was one of my great mentors when I started my career. So, Michael, thank you very much for joining us today, and we are looking forward to hear your presentation, which will be very interesting. And please welcome with me, Mr. Michael Dundry.
Thank you very much for those kind remarks. Can you hear me at the back? I prefer not to use the microphone, a little more natural for me, so thank you. And thank you kindly, Dr. Eldamadi, for the invitation. It is a bit of a quote unquote homecoming for me, having spent a good number of years here at Western, and I'm always delighted to come back. I mean, the title speaks volumes, and it is reality. It's not make-believe. And my hope is that I go through my presentation, all I'm going to do is just give you glimpses in the world of civil engineering in a municipal context. And you'll see, certainly when I was, in your shoes in those chairs, sitting back, not exactly knowing what the world of civil engineering would hold for me when I graduated, you see that the world is your oyster. I'm envious of those of you that certainly are going to be graduating this year, but those of you in the program, and you'll see that the world of civil engineering, and particularly in a municipal context, is like no other time in history, in my opinion. So with that, I'm going to rush through the presentation. There's an awful lot of material that I think you'll be interested in. And without further ado, let's get started. So that's the overview of the presentation. There's a number of themes, a number of topics, but basically what I'm doing is I'm covering the gamut of what goes on in civil engineering in a municipality. So how many of you from the City of Toronto or the City of Toronto area, just so I get a sense of, because I go through some of these slides and I got streets named. Okay, so not that many. Okay, so City of Toronto, as Dr. Eldamadi said, the biggest city in Canada, and very populous and very dense urban development, particularly in the downtown core. I'm not going to go into the details. On the bottom, I show one of my favorite slides is Toronto prides itself in having 11 beaches along the waterfront, which has been a real passion of mine to help in the endeavor to clean up those beaches so that they are safe for swimming. And more on that in a few minutes. So it's important to look at the context in terms of what we're managing and what we're dealing with in terms of infrastructure. So often forgotten is the water infrastructure. It's underground, or we've got sewage and water plants that are out of sight, out of mind, but hugely important in terms of servicing the life in a municipality. And then we got the transportation infrastructure. I mean, you see that, and you see sort of its state visually, but also a huge source of concern for us in making sure that it's maintained to be safe and operable at all times. I want to highlight, I'm not going to get into a lot of details, but there's 900 bridges. I know that there's a few of you specializing in structures. It's a huge body of work for us. We're obligated by provincial regulation to go in and inspect these bridges on a 2-year cycle. And coming out of that, in terms of what we assess and identify, is embedded in a capital program, because we, from a due diligence standpoint, we need to make sure that those bridges, most critical infrastructure from a civil standpoint, are properly maintained. Okay, I want to give you a bit of context in terms of the city of Toronto, just sort of set the stage in terms of the rest of the presentation. So what I've done here is shown the build out of infrastructure. It's shown to be water, but it could be anything. It could be roads, it could be sewers, but just to give you a sense in terms of the growth of the city. And so take home message, downtown core, oldest infrastructure on the, so downtown core is the oldest infrastructure. And so it happens to be an area of particular focus for a number of different reasons. This is, again, downtown area, shaded in pink, is where we got combined sewers. We got a single sewer servicing both sewage as well as stormwater runoff, and a huge problem from an environmental standpoint in terms of water quality impacts to our rivers and the waterfront, particularly when it rains. And again, a huge problem and a huge body of work that we're dealing with in respect to that. Which segues into this. Toronto has been identified as one of 43 polluted areas of concern in the Great Lakes Basin. And there's been a huge amount of level of effort. We've got a multi-year plan to actually deal with the pollution problems associated largely with our sewer discharges. And again, that's been another passion of mine, and pretty much my entire career, one way or another, has been spent in dealing with some aspect of that. Then we need to deal with extreme storms. Climate change is here and it's real. And what we're seeing is far more frequent, intense storms that result in urban flooding, both in terms of surface ponding as well as sewer backups and basement flooding. But as well, huge impacts on infrastructure. We've had washouts of bridges, and I've shown in that picture. Situations where we also have turbidity plumes from rivers that flow to Lake Ontario. Lake Ontario happens to be a source of drinking water for the city of Toronto. And again, issues that causes some concern in terms of being able to operate our water treatment facilities under these extreme storm conditions. Okay, so here we go, civil engineering rules. So one of the things you probably don't really think about is our role in terms of supporting development and growth. And so what I've got here, if you take a look at the top areas, Toronto's growth projections to 2051, its forecast, this is both provincially as well as the city planners. The Toronto's population will grow by 700,000 effectively in less than 30 years. And so it's a huge challenge for us because, again, if you think of my earlier slide with the downtown core and that old infrastructure, well, that old infrastructure wasn't designed to support the kind of growth that we're seeing. And you'll see a couple more slides in terms of how significant that is. So it's incumbent upon us then to think ahead, to plan for the future, working with our colleagues in the planning department to map out where they are forecasting future growth to be and making sure that we've got the necessary infrastructure to support it. In Toronto, we have a very strong environmental focus, a council that has really directed green in so many respects. I use green pretty loosely. So when you're building in the city of Toronto, you have to abide by what's called the Toronto Green Standards, and that's to provide on-site stormwater control. So green roofs on buildings are commonplace. And we're looking at energy efficiency in terms of how these buildings are designed. More recently, the city of Toronto adopted what's called Transform TO Climate Action Plan, looking at a net zero GHG emissions by the year 2040, which then forces the developers through their engineers and architects is to make better decisions in the design of buildings that are built in the city. So development growth, this is reality now. Each one of those specs, I apologize for the resolution, represents a development either queued up for waiting for approval, and what sometimes in many cases the approvals are through my shop, where the engineers in my group are actually looking at the ability to actually service that development, particularly when it's a high-rise condominium, and making sure that we've got the infrastructure to service it. But in many cases, those dots represent active construction sites. And so these are staggering numbers for a guy that's been in the industry his entire career. We have 230 tower cranes in place in the city of Toronto, not just the downtown core, but across the city. And forecast, and I'm speaking to my colleague in transportation who has to issue permits for lane occupancy for construction staging for these developments. She sees about 100 applications queued up to the end of the year. So we are the highest number of tower cranes in all of North America currently. The second highest is City of Los Angeles at only 50. So as you can see, get a sense of the kind of growth that Toronto is seeing today and forecast for the next number of years. So on the geotech side of things, what I haven't shown on here is that we were working collaboratively with called the Oak Ridges Moraine Group. This is the conservation authority. So geotechnical staff there has sort of mapped out a three-dimensional profile of the superficial geology and groundwater regime across the city of Toronto, but it goes up right up to the Oak Ridges Moraine. Critically important was to have a first cut in terms of what the groundwater regime is in a particular location. If you can imagine, when we got deep foundations, several floors of parking below grade, you inevitably, if you're tying into or your foundation is in an aquifer, there's going to be huge pressures with respect to relieving that hydrostatic pressure on the building. Normally, we would have allowed a direct discharge to our sewer system, but we can't now. We just don't have the capacity. So it forces then the geostructural engineers to design the shoring for the system, sometimes with cutoff walls, so that they basically are creating a bathtub in which that building then is going to be situated. Again, a huge body of work. We've led the development of a strategy to deal with this and looking at new technologies, both in terms of the design as well as construction, but a huge body of work that, again, is pretty recent. These are a couple of large tracts of land in Toronto that are being developed. And you can see this is Toronto, as I said, it's completely built up. What is happening now, it's intensification within these city boundaries. And those are two applications. One is sort of north central and the other one is in eastern Toronto. Okay, so now we've got an issue with respect to, again, how do we service this kind of intense development that's going on? And this is, again, on the sewer side, a major project. For those of you that know York University, York University is the green blob at the top of the screen. So that's Finch Avenue, Steeles Avenue, which is sort of the limits of the city of Toronto, and going down to just north of the shoreline. And so that tract of land is all being serviced by an existing sanitary sewer system that was, built, in the 20s and 30s. And so right now the challenge is how do we then support the growth that's anticipated, and you can't service it with the existing system. So a take-home message: we've got a series of tunnels as well as local sewers and storage tanks to provide for that additional growth, and then reduce the overflows into the Humber River, which is one of the major water courses in the city of Toronto. So again, these are staggering numbers, even for me. The total project cost to be constructed between 2052 and 2025 to 2032 is in the order of about $700 million. It's a major project. We're currently in the design. We went through what you need to do is go through an environmental assessment process to evaluate options, and we're currently into detailed design for that solution. Okay, infrastructure renewal. So going back to my earlier slides, it's an old city with old infrastructure. Well, that old infrastructure needs to be replaced. It's not going to service us indefinitely. And that when the system fails, it fails big time in a Toronto context, particularly in the downtown core. One of the areas of real focus for us is dealing with our aging sewer and water distribution system. And so here are a couple of examples, again, real life, where basically if you've got a major water main break into downtown core, you're basically shutting down that entire arterial road for some significant amount of time, and there could be loss of service to the buildings and to the residences and to the businesses. And so the staggering numbers in terms of what the backlog is as it stands today. So some of these numbers are fresh off the press. I mentioned Dr. El Damadi. We are in the middle of a budget review process for 2023, which council is now hotly debating. And so a lot of these numbers are extracted from that. So again, this is real life in the city of Toronto context. This gives you sort of a sense, just thinking back in time in terms of how did we build up the city, going back to those earlier slides. So I think it's important, again, this water main data is just representative in terms of the situation we deal with all of the infrastructure. But we have 9% of those water mains that are 80 to 100 years old, well beyond their level of theoretical service life, and 15% over 100 years old. But this is where the engineering comes in. So age doesn't tell the whole story. And so we did an awful lot of analysis when I was in Toronto Water to look at the fundamental mechanisms of water main failure. And found that when it's all said and done, some of the old water mains in downtown Toronto are cast iron mains, very thick walled and sandy, good draining soils. And they're in excellent shape as shown on this slide. We have water mains that were built post WW2 in the northern area of the city, the suburban areas of the city, that were spun cast water mains and in very corrosive clay soils. They need to come out of the ground. It's been one of the challenges is getting to those water mains before they fail and cause major disruption. So there's a huge program to deal with water main replacement. And so this is some of the analysis that we had done. So back in the day, we had something in the order of 13 to 1,500 water main breaks a year. The slide with the blue graph with the blue bars is indicative in terms of the seasonality of the water main breaks. We get most of the water main breaks in the wintertime when you have frost penetration, and so you've got movement to the water mains, and then they're fragile, and so they break. And so we're on the road to replacing and renewing that infrastructure targeted. So we're not replacing every water main just because it's old. We're targeting those that we feel are at or close to the end of their service life as a priority. This is something else that we did. We created mortality curves for each class of infrastructure. So to try to anticipate when we might have to actually deal with the renewal of the infrastructure in advance of actually running that infrastructure to failure. And then basically what you do then is then you come up with a capital program that deals with the needs that you've identified. And then you're identifying individual discrete elements of your infrastructure that fit the criteria that you've established, so that you've got a way of addressing the need based on the limited funding that one has. So this is the good news in the Toronto Water context. So the red line shows the infrastructure backlog in 2022, and it's slowly coming down. So to the point that by 2032, they will have pretty much chipped away at their entire infrastructure backlog. And this is sewers, water mains, sewage plants, and water plants. It's all in. So $7.3 billion of their capital program over the next 10 years, staggering numbers, is devoted towards dealing with the renewal of infrastructure. And almost $700 million is allocated for 2023. So that was just water, right? A big basket of assets. This is now the city as a whole. So water, transportation, we have building infrastructure. So again, staggering numbers, but I think if you take a look, this is again hot off the press in terms of the 2023 budget submission. There's been an increase of 49% in funding directed towards state of good repair needs, i.e. infrastructure renewal. Now, again, I come back to say, these are numbers that you couldn't have imagined. Certainly at the start of my career, where there's been this concerted effort to invest in the infrastructure in a manner that you couldn't have imagined. So fast forward, this is reality. So these maps are generated by another group that I have that is trying to coordinate all of these infrastructure renewal needs to the point so that we're not just locking up traffic in downtown Toronto. For those that, if you turn on the TV or radio, you'll see that there's an awful lot of frustrated residents and businesses trying to get around in the downtown core, given the amount of construction that takes place. Our objective is trying to limit the impact so that we don't have construction activity on parallel major roads at the same time. But so the map on the left is just infrastructure. It's largely being replaced through my shop. So it's sewer and water main infrastructure. The one on the bottom right is everything when you add the utility companies in. So you see that, again, and this is all civil engineering, the amount of work that takes place. And this is just in year one. This is just 2023. Okay, so some real life big infrastructure projects. So the Gardiner Expressway is a flashpoint. I mentioned Dr. El-Damati will be front and center in front of council defending the need to invest significant dollars in the renewal of that expressway. So $2.3 billion is our estimate in terms of what the rehabilitation needs. The elevated section, which is the source of much concern and much debate and much interest, is about 60 years old, and it's at the end of its service life. It needs to be replaced. Our challenge is to actually get to replacing it in advance of it running to failure. We run inspections. So for the structural engineers in the crowd, we run inspections for the elevated section twice a year to make sure that we've got things in order. And if we see that the cover concrete is about to fall off, to get to it before it actually does, because it's a public safety issue. So I'm going to show you the middle there, contract 1 Jarvis Street to Cherry Street. An innovative approach is what we use, successfully completed using accelerated bridge construction, which we're quite proud of. And our hope is that we use that approach for the remaining 4.5 kilometers of the elevated expressway. So accelerated bridge construction, basically in a nutshell, to summarize, what we did for 1.1 kilometers is actually saw cut out sections of the elevated expressway. So it was girder as well as the concrete deck, and out, and the materials, both the concrete and steel, were recycled. Separate and apart from that, we were prefabricating panels. So I noted there, some in the order of about 300 tons, 42 meters in length, 5 meters in width. And they were fabricated at a city-owned facility. The contractor basically established a prefabrication shop on our land. So the neat thing there was that we were able to quality control the production of these panels. There are about 410 discrete panels. Each one was different and precisely measured in respect to replacing what we had removed. So you'll see a picture on the bottom right. That doesn't, it's not as basic as it appears there, because each panel had a discrete number. It's kind of like a jigsaw puzzle. And so as a panel was removed, they had to organize themselves, stage the work in such a way that a panel that was removed could be replaced efficiently, as opposed to having to go into the yard and move panels around. So all of that pre-planning took a significant amount. So the pictures in the middle show the hoisting operation, both in terms of the removal as well as the installation. And now the neat thing here is that, again, we pushed the envelope on this. We hadn't done anything like this before in the city of Toronto. In fact, in North America, to our knowledge, no one had done anything of this scale in an urban center. There's lots of accelerated bridge construction in terms of new construction in open fields, but not when you're in the downtown core of the city. And for us, the advantage there was, if you take up a lane of traffic on the Gardner, there's a huge impact to the road users. But as well, for this kind of construction, because it is noisy and dusty, there's a huge impact to the local residents. So what it did, we were able to shrink the construction schedule by about 40%, and then ultimately reduce the overall impact to the local community. Okay, transform the municipal right of way. So these are some major projects that are underway. Again, it's the rebuild of the city, but in a very progressive way. So 6 Points Interchange is in the west end of the city, in the former city of Etobicoke. It was basically, on the picture on the left, shows it basically it looked like a highway interchange, series of bridges and ramps on and off ramp. And it really didn't speak to sort of intensifying, because it was really just, having development, residential development right next to a highway. So the planners, working with the local community, came up with a completely wholesale revamp of the design to the picture on the right, which is the finished road layout. And I'll get into that in a little more detail. Here's just a picture of what went on during the demolition of those bridges and ramps. There was much media interest around that because nobody had seen anything of that scale. And basically, one entire section of the city was literally under construction at the same time. Meant major traffic impacts that we were dealing with. So here's what the layout looks like. This is in schematic. And so cross-sectional view on the left, artist rendering on the top right, and then sort of a bit of a cross-section on the bottom right. So a couple of things that I wanted to highlight. It's a complete streets approach. This is in vogue now across the whole city, but internationally. You're looking at the municipal right-of-way, basically the road allowance, and you're maximizing its use for multimodal, right? So vehicles, cyclists, pedestrians. And at the same time, from a water quality standpoint, you have to drain all of that, the stormwater that falls on that streetscape. And so what we've done very innovatively, series of what you see at the bottom shown schematically, a series of kind of like gate cartons. It's you know, there's a number of vendors, but basically you're intercepting that stormwater and allowing it to infiltrate in the ground. What doesn't infiltrate, you end up picking up in through perforated storm sewer pipes, and then they get discharged. But you're trying to maximize the overall environmental impact of that road network to the extent that you can. And this is what it looks like. So on the left, it's a picture post-construction. And on the right is that series of their silver cells, but those industrial size egg cartons that basically take the stormwater and infiltrate. So here's a couple more examples. They're still over to my shop on the design side, but these are some artist renderings. So the north end of Yonge Street by Mel Lastman Square is on the left. Again, it's a complete streets approach. The proposal there is there are 3 lanes of traffic, 3 northbound, 3 southbound. Take 1 lane of traffic out of commission and basically extend the sidewalk area, the pedestrian area, to provide for outdoor cafes, but more pedestrian-friendly environment, while at the same time incorporating dedicated bicycle lanes. On the bottom right is the south end of Yonge Street, basically to take cars off limits, and you now turn it into a pedestrian-friendly area. Gardner Expressway. So to the east end of the Gardner Expressway, it's kind of I'll say an industrial area. So with the rebuild that we are doing now on the elevated section, what do you do at grade? I mean, so the overall objective was we're going to build new infrastructure elevated. We need to spend some level of effort at grade. And so there's an artist rendering in terms of what they're expecting from us in terms of on the engineering and the design of the at grade elements along Lakeshore Boulevard. And this is the east end of Scarborough, a completely new project that, again, take home message here is we're providing for pedestrians, for dedicated bicycle lanes, as well as for vehicle traffic. Improving water quality, just going back to my introductory slides, huge body of work in Toronto. It's a real priority. We want to see ourselves delisted as a polluted area of concern in the Great Lakes Basin. So there's been an awful lot of work. So I'll start with this outfall project. Sad to say, but I started my engineering career on the pre-design for this outfall. So here I am, towards the end of my career at the City of Toronto, and we're finally building it. So basically, long story short, there's a new outfall that extends 3.5 kilometers into the lake bed in rock into Lake Ontario, with a series of 50 diffusers for the last kilometer, and so diffuser ports basically sitting at lake bed. So all of the modeling that was done for the design of this project was done with the approvals of the Ministry of Environment and Climate Change because of the fact that we want to maximize the initial dilution so that basically outside of the mixing zone, we meet water quality objectives for a series of parameters. So there was an awful lot of work on a proper design and with a limited amount of head that we have to drive the flows through that outfall. So those are some pictures with respect to construction. It's 7 meters in diameter, 3.5 kilometers. There's no way to describe that unless you're there to see it firsthand. It's an absolutely massive undertaking. So the good news is the tunnel's completed. We're now installing the risers for the diffusers. Similarly, another project which is now looking at the cleanup of the Don River. The Don River happens to be one of the major water courses in Toronto. It has the dubious distinction of being one of the most polluted rivers in all of Canada. And it's been a real problem for us from a water quality standpoint. It flows into what's called the Inner Harbor. If anybody's been to Center Island, the water body between Center Island and the mainland is called the Inner Harbor. And the Inner Harbor as well sees the discharge of some of the biggest combined sewer overflows in the city. Huge problem from a water quality standpoint. So ultimately, to delist us as an area of concern, we needed to clean up the Don River and the Inner Harbor. Many, many years in engineering planning, many, many years on the engineering design. And so what we came up with a series of deep tunnels, most of them rock, but there's one that is in soft ground. So the main stem, which is this Coxwell bypass tunnel, we just completed the construction of the main stem. Yeah, 10.5 kilometers up the Don River Valley. We're down in some depths down to about 80 meters. And so what needs to happen now is the connection of the sewers that will flow into this tunnel so that they don't flow into the river. We do provide for some overflows in the event that the tunnel is at capacity. But the design of the tunnel was premised on taking our historical rainfall records and doing computer simulation modeling to come up with an assessment how big the storage needed to be to support our end objectives. So you see the pink tunnel coming down, and it connects up at our Ashbridges Bay Treatment Plant, which is where that outfall project is. And as well, the next leg of it is the Center Harbor West Tunnel, and we're currently in detailed design for it. So ultimately, when it's all said and done, we're cleaning up the lower Don River and the Inner Harbor, and the most significant project of its kind nationally from a water quality standpoint. Integrated pumping station. So now that we've got this deep tunnel, you have to pump the flow out of it and provide treatment. And so the idea being we're going to have a dedicated high rate wet weather flow treatment facility on the site of the Ashbridges Bay Treatment Plant. The Ashbridges Bay Treatment Plant deals with human waste. And then what we're going to do is the effluent from that high rate treatment goes to the plant to be disinfected, and then the flows out through that outfall that I just showed. So it's all integrated. Separate and apart from that, we've got two aging sewage pumping stations that service the Ashbridges Bay Treatment Plant. And they're pretty much at the end of the service life, and they needed to be replaced. So from a maximizing of the approach, what we decided to do is to build one large pumping station that basically meets the wet weather flow needs as well as the sewage needs all into one integrated massive pumping station. We're just in the throes now of finalizing detailed design. We hope to get out to procurement later this year. So the numbers are staggering. It's a single facility to the tune of estimated currently at $1.2 billion. And it's probably one of the largest pumping stations in the entire world. But again, from the standpoint of the city, of huge value to us, both in terms of sewage and to support the sewage plant as well as wet weather flow treatment. Okay, Earl Bales Park, the Earl Bales Stormwater Management Facility. This is a number of stormwater ponds. This is iconic for me for a couple of reasons. One, it was at the time the largest stormwater management facility in the province of Ontario, and this is nestled right in the heart of the city of Toronto. But we have plans for 170 facilities across the city. This is designed largely for water quality improvements because the flows from this drainage area flow right into that Don River. The bottom is sort of a representation of where it lies relative to the topography. The neat thing about it, above and beyond the fact that it's a water quality facility, is that we're drawing water out of the pond in the summertime to augment the irrigation needs for a city-run golf course. And in the wintertime, we only have one ski hill left. And apparently was told at the time that stormwater, because of its impurities, is a great source for snowmaking. And so there's a local ski hill from which water is drawn from this facility to support their operations. Stream restoration. There's no way that anyone would think of, back in your shoes, of the fact that as a civil engineer that we would be involved in bioengineering of streams. And yet that is a huge body of work, not just in the city of Toronto, but it is in vogue now, arguably internationally. And so basically, we used to, back in the day, concrete line trapezoidal channels, no more. It's all bioengineered. And so what we're trying to do is to address the channel hydraulics, while at the same time creating fish habitat and maintaining overall ecosystem health for the area. And so there's guidelines and design guidelines to support that. In Toronto's context, these streams are hugely important, both from an ecosystem standpoint, but we have trunk sanitary sewers that crisscross these riverbeds. And you'll see the picture in the middle, that's a trunk sanitary sewer that's exposed, that was exposed during a major storm. So our challenge is to get to those reaches of the stream before they undercut to the point that they're actually impacting critical infrastructure. So that's top left is a before and the bottom is an after. And it was kind of neat in that particular project is to see actually ducks and small fish actually then re-migrating to those areas because we had done such an amazing job both in terms of the cleanup as well as the overall function of the stream. And what I should mention, all those little red lines, those reaches, those are areas that are mapped out for future restoration. Again, as budgets permit and as well as we establish priorities based on need. Okay, I'm just going to rush through climate change. And again, I'll go back to the extreme storms and what they've done in a Toronto context. So we have an overarching plan to deal with the impacts of these extreme storms. And it's a stormwater management challenge for us, admittedly within a completely built up area. So basically, if you take a look at the topography of the city of Toronto, I often refer to it as a series of soup bowls. So if you're at the bottom of a soup bowl, when that sewer system is overloaded during these extreme storms, you're going to get flooded. You're going to have surface flooding, and more often than not, the water can make its way into the sanitary sewer system and surcharge that system and back up sewage into your basements. That's a given. If you're at the top of the soup bowl, never been flooded, not likely to be flooded because you're in high enough ground. The challenge for us is that if you're in the bottom of the soup bowl, you may have had a long history of having sewage in your basement. And you can imagine the hue and cry, both in terms of the public as well as our political masters. So the charge to us was to fix this problem once and for all. So each one of these study areas is a community. And so represented here, sort of the schedule in terms of the work that we've done. And we've had to tailor make a solution in each of those communities. This is what a typical construction site looks like when you're in the community. I'm not going to get into a lot of detail, but suffice to say that a good portion of Toronto Water's capital program is dedicated towards this basement flooding protection program. So again, so far as this year is concerned, they've got something in the order of just $2 billion over the next 10 years in terms of sewer, in terms of stormwater management upgrades. Not going to go through the details, but suffice to say that it's basically tailor-made. Sometimes it's upsizing sewers. Sometimes it's installing storage tanks or stormwater ponds. And here are some visuals in terms of real life. That's a stormwater pond under construction at the left, and then post-construction. This is a stormwater tank. Basically, our whole objective is rather than having that water pond in those low-lying areas, intercept that stormwater and redirect it away from those urban centers. That's the overall premise. Council charged us to provide for a service level of a 1 in 100 year storm, which is unprecedented in a completely built up urban area. Those storm systems were designed for a 1 in 2 to a 1 in 5 year return. So here we are, really to the limits in terms of what's imposed for new or greenfield development. This is what a typical area. This is a residential community. Each one of those boxes represents a sewer upgrade, and most of the sewer upgrades were storm sewers rather than sanitary sewers, which was the common practice back in the day. Here's the biggest project of its kind. This is a massive soup bowl, if you will. This is in the south and to the west of the downtown core, Fairbanks Silverthorne Tunnel. And again, we are just in the throes of constructing the backbone of the system, which consists of a deep tunnel. And then what we're doing is now it's a combined sewer service area, and we're constructing a series of storm sewers that take the storm drainage off the roads, dump it into the storm tunnel, rather than dumping it into the existing combined sewers, which carries sewage. And so we expect a huge improvement to the local water course, as well as alleviating a chronic basement flooding problem. $400 million is what's been estimated to service this area. Okay. Transit expansion. I mean, it's in the news in Toronto all the time. I'm not going to go into the details. Suffice to say, huge volume of work. So all aspects of civil engineering. The challenge in my shop is that we have to service that development. A number of these stations are quite significant. And so we need to move some of the underground infrastructure, and that has to be done in accordance with our requirements. In addition to that, again, I go back to the first slide with the amount of growth that's expected in Toronto. The planners would like the planners would like that growth to be oriented around these transit upgrades. So you have transit-oriented communities to help subsidize or support the massive investment that is being made, both in terms of light rail and heavy rail transit systems. So that's the City of Toronto. That's just what's in play in the City of Toronto. Now, when you take a step back and you look at it more regionally with the province of Ontario and their Metrolink system. So each of those dotted lines represent an expansion to their existing network. Again, huge body of work. When you consider all the bridges that need to be installed and or the existing bridges that need to be replaced. Okay, intelligent engineering systems are almost done. So something that you probably wouldn't have thought about. So as engineers, there's a body of work that we have underway to protect our source water. To go back to that earlier slide where I showed that plume, well, that plume could actually impact our water treatment plant intakes. And so what we have working with collaboratively with our area municipalities to either side of the City of Toronto, working on a decision support system. It's a computer simulation model wherein we feed field data instrumentation that is in Lake Ontario, both in terms of currents as well as water quality, to feed the decision support system, real-time simulation in the event that there's a spill. And a spill could be a massive sewage spill, or it could be a petroleum pipeline break. We've got a number of petroleum pipelines that cut across the city. We've got a major storm with the undercutting that's entirely possible. With the view that on the bottom is just an example of a spill that is a snapshot in time through that simulation, that we can inform whether or not we may need to shut down a water treatment plant intake. We've got 4 water treatment plants that service the City of Toronto. And again, it's from a human health standpoint. So this is critically important. This is still a bit of an evolution, but these are images hot off the press in terms of where we're at with that model development. And then on the traffic side, intelligent transportation systems, where that's a control room in a remote area that is under high security, and the Transportation Services Department has these remote cameras which are tethered to this central station where they can actually monitor traffic movement, and they can affect traffic signal timing as well as adjust the variable message signs. They have an ability to pick up cell phone signals across the city, engage whether they're vehicles and or gauge the level of traffic that exists in a given intersection, and make a decision real time about whether they need to adjust the signal timing either in that street or the adjacent streets. And all of that is being closely monitored. And here is an example where they've got shown in the representation in terms of the monitors that currently across the entire network, and all of that is controlled centrally. Okay, capital program budget, so that you know that I'm not blowing smoke. This is the Toronto's capital program budget for the next 10 years. And so $49 billion, it's the biggest ever capital program in the city. And you can see right at the very top, water, transit, housing, and transportation. Those are all civil engineering focused activities. This is my world. This is my division where we have been delivering, as Dr. El-Damati said, about $1 billion in capital every single year. So the 2022, where that line is where we are currently, but you can see what the forecast is, a continued increase in the amount of engineering and construction that is expected from my shop over the next 3 years. Okay, I bit over time, but that's the presentation.
So we have room for maybe a couple of questions.
Thanks for that really interesting talk. I wonder how you, in your role, manage, with the longer term vision of the issues you're dealing with. How do you deal with city council, and what strategies do you have to use as an engineer to navigate the politics of what might be shorter term views on council?
I mean, that's a daily challenge for us, admittedly. And I can tell you, partly it comes down to communications as well. I take great pride in our staff reports that we take the challenges to take the engineering and the engineering lingo that is commonplace for us. And to, I wouldn't say dumb it down, but to translate it in layperson's language, and that's been a real challenge. I can tell you that, my entire tenure at the city of Toronto has been that they will challenge, and I mean, it's their right to challenge. But once they get an understanding of what is doable or not, they typically will side with you and say, aha, I hadn't thought about that. As I mentioned to Dr. Eldamadi, that what will be a focus in the next couple of weeks, and if you're watching the news, I'll probably be front and center with respect to that Gardner Expressway. They made a decision years ago. We are implementing as good engineers. We're just following council direction. But there's a faction that will continue to want to debate to go back and revisit. But we're at the point now where it's at the end of the service life. If we don't get on with what we need to do, we may literally have to shut down this expressway from a public safety standpoint. So good question, but it's just part of the having to navigate the politics. It's the engineering is, in some cases, it's the easy part. It's not getting the politics to get to where you need to do it. It's challenging.
Other question? Yeah.
I just have a question about electric vehicle infrastructure and how that fits into your plan. Specifically, I'm wondering, do you have, or can you think of or envision any need for being able to discern whether vehicles are electric or internal combustion engine on any thoroughfare or in any parking facility? And if you have any technology at the present time, or if you're interested in knowing more about such technology.
Well, on that, fairly specific question, I would refer you to, I'm not deflecting the question, but there's a whole group. We have an environment and energy office that is really at the leading edge of advancing this Transform TO initiative. My colleagues in transportation who are actively engaged with them. And then we've got Toronto Hydro and the Toronto Parking Authority that are all engaged in the setup and installation of EV charging stations, for example. And again, a real priority for city council and with some councilors in particular, and I can link you up with them, huge interest in the city. And in fact, if you speak to the politicians, we're at a snail's pace in terms of the implementation, both in terms of within the right of way as well as parking facilities at the city limits. Well, that is the direction, there's no question.
Any other question? Person?
One general question, how do you consider climate change in all your designs, especially with weather extremes? And do you think you're doing enough?
Another loaded question. That's been the topic of much discussion as we're going through the political arena and the review of the budgets that we have. And again, there are many that feel simply that we're just not doing enough. I can tell you from where I'm sitting, we can't keep up with the demands. I mean, these are, when you take a look at what we're doing on the urban flooding front, if you could only drive through these neighborhoods when we have active construction, they literally look like war zones. The notion that we're raising the design standard where possible, because it's not possible everywhere, from a 1 in 5 year return storm to a 1 in 100, there's going to be the climate change activists that will say, well, 1 in 100 is nowhere near what you ought to be designing for. But when the bar has been set so much higher than where we are, it might not be the ultimate, but man, the higher level of control that we are providing is unprecedented in a fully urbanized context. We're not starting fresh in greenfield. This is shoehorning in the fixes that I quickly went through in a completely urbanized area. So you're right, but the pressure is on, no differently than the EV charging stations, as we need to be doing more. That's sort of that mindset. On the bridge infrastructure, for example, my hang up has been working with the conservation authorities, so they manage the ravines. They manage ravines, so they've got the floodplain modeling. If we need to rehabilitate a bridge, and we know that bridge cross-section is a bottleneck, what do we need to do to make sure that we're actually designing for, right, that extreme storm condition, whatever that may be, so that cross-section then is representative of a design storm rather than the previous design storm that for which that bridge was constructed. So that is just, again, that's an evolution. And so we seize the opportunity more than anything. What I forgot to mention, my take-home message on the climate change front, if a piece of infrastructure needs to be renewed or replaced, seize the opportunity rather than replacing one for one. look at what the climate change needs they represent, and so that you upgrade based on that rather than.
One more question, say anything? Yes.
You had an extra $10 billion today. How would you spend it on the city infrastructure?
Don't need something to read up.
I had a dream, yeah. Oh, man, that is a tough question. And it's not one for me to answer. It's the question, it's the politics. Right? And it may be for some, it's just installing the EV charging stations everywhere. For some, it would be some aspect of climate change, retrofitting buildings, which has been a real priority as well, so that they become more energy efficient and reducing our GHG emissions. So, I mean, you saw the problem that I've got is that I know too much in terms of the needs, and it's not just in one particular area, it's right across the whole. But, I got to give credit to my team and the divisions that we support. They've got a big job, right? You've got all of these competing needs, and they're competing not only in time, they're competing in space, and they're competing for the limited dollars that we have available. So they're doing the best that they can with all of those challenges. So, forth. Great question. If I only had, yeah.
I have a quick comment before we. As an owner of the condo of Toronto, I see the 200 place, and I have a nice view now on the lake shore, but it's diminishing every day with the towers coming up. So, what do you think is going to be the future of Toronto with all that development?
Well,
As a city.
no. So I'm not evading the question. I'll tell you a little story. So when I was in water, we're trying to map out what the future growth needs were about the inner harbor. Kind of like you, I'm saying, what would the future of that downtown core look like, right? And so it's not for us, the engineers. How are we to know what the future holds from a development standpoint? So you go to the planning department. The pat answer that I got, Michael, we've got an official plan that takes us 20 or 25 years out. But I'm saying, no, we're building legacy infrastructure. This is for future generations. If we're tunneling in rock, we want to do this once, so we want to do it right. How big, what sort of volumes or flows do we need to service in the future? Will it be a Manhattan? Will it be a Hong Kong? And so the problem, that was a question that was asked probably about 10 years or so ago, and then there were no answers. Ask a question now when you've got the 230 tower cranes that are in place today, and there's another 100 queued up. I cannot imagine. The neat thing is that I think that you'll see more distribution of those towers along where the transit investment is made, rather than just focus on the downtown core. That I think is you're going to see in for real. And because I think that's a good thing. So you're directing development to where you've got the transit systems, and again, helping meet our climate change objectives and less reliance on GHG on greenhouse gases.
Before we close, I have to say something that Michael is gonna retire from the City of London on February 17th. So I think it's a good opportunity for us today to thank him for his great career, for his support to Esther all over those years, for the great things he has done for the City of Toronto, and also to wish him all the best in the coming years. With us, Dean Coley. Maybe he wants to say a few words before we do the closing.
Oh, my goodness. I'd honestly expected to sneak in quietly and say a quiet congratulations to Michael. And I'll do the quiet maybe a less quiet congratulations to Michael, but congratulations on your retirement. And I echo everything that Ashraf said. I think it's fantastic that we have alumni. First, that we have alumni that do us such credit by having fantastic careers in engineering, but also alumni who are always willing to put them for Western engineering. So absolutely appreciated, and I'm delighted I managed to get here in time to say this, even if I get ambushed by Ashraf. So thank you, Ashraf.
I have two small gifts to Michael. One of them is a nice Western pen, and the other one, because also I like the Harbourfront, walking in the Harbourfront.
Very kind words, kind of natural. I mean, it's my pleasure, as you know. I hope that you can sense the passion in the work that we are doing. And what we've done and the career started here. So I wish you all much success in your studies, but more than anything is to look at what I presented today and know that there's a really, really bright future for you ahead, and I wish you all the success in your career. So all the best to all of you. See you next week.
Go tomorrow, yeah.